I'm April Latham, and I work for the USDA Agricultural Research Service. And back in 2005, we started doing air quality work related to animal production throughout ARS, and we were one of the locations here in Kimberly, Idaho, that was chosen to start doing this type of work. We've been working on approximately 4 different dairies throughout southern Idaho and 2 dairies in California, where we've been trying to look at whole farm emissions and really understand what type of emissions you get in the different source areas on a farm. So looking at the animal housing, looking at manure handling and storage, looking at support animal housing, and long-term storage of manures. And so we tried to do several different types of facilities that were common to southern Idaho and the western US, which is quite a bit different than dairy production in the eastern and midwestern regions of the United States. We tend to have more open lot dairies. We have some freestall dairies, but the support animals are still on open lot dairies. Most of our manure is either handled as a solid and composted, or some is just stacked. Or we also have some dairies that will have a significant amount of their manure stored as a liquid in a lagoon type system. And even on the open lot dairies, there's always manure that comes from the milking parlor that's stored in the lagoons. So we put a lot of time and effort into picking out the dairies that we work on. They have to be fairly well isolated in the landscape in order to feel like I'm getting a really good estimate of emissions from the farm. So we tend to pick dairies that are isolated, or at least don't have a lot of sources of methane or ammonia upwind from them. And I also try and pick dairies that the layout of the dairy itself, where they have the housing and where they have manure storage, tend to be in a way that's perpendicular to the wind, so that I can do a really good job of isolating the different source areas on the dairy to make sure that we're getting really good representative emissions numbers from those different sources. So at the dairies, we focus on measuring ammonia, methane, and nitrous oxide from the different source areas. And the equipment that's behind me is the equipment that we use at the dairies. We have multiple units of these. They are called Open Path FTIRs. And so what they do is they pass a beam of infrared light from the detector here to a retroreflector that's behind me, which bounces back into the instrument, and it's measuring the concentration of these different chemicals within the path length, which is really nice because it allows us to get a better average concentration from a larger area in the dairy than you would if you were just measuring at a point source. And so then the data that we get with FTIRs, the concentration data, is then matched up with weather data that we get using a 3D sonic anemometer, as well as your basic temperature and wind speed monitors. And we combine those two, and we use modeling to estimate an emission rate from each of the different sources. To get an overall measurement for the farm, is we add the different source areas together to get the total emissions from the whole farm area. There are quite a bit of differences in emissions throughout the year, especially here in southern Idaho. We have very distinct seasons. So your emissions are going to be different in the summertime when it's hot and dry versus in the winter when it's cold and the ground could be covered with snow, or the lots are frozen and the lagoons freeze over. One of the unique features of dairy production in the western US is that a lot of our dairy cows are housed in open lots. And so these are open corrals with dirt floor and then usually a concrete apron. And the manure from the lots are harrowed in the summertime, or some guys sometimes they'll stack it up into smaller piles within the lots. In the wintertime, they tend to scrape the manure and pile it, and they also tend to use straw bedding a lot of times for the cows during the wetter months, which also gets scraped and piled in the lots. So you have a manure source in the lots that is producing ammonia, methane, and nitrous oxide, and then you also have nitrous oxide being produced from the soil within the lots, because they're continually getting manure and urine applied, and nitrogen builds up over time, and then that nitrogen can be denitrified and lost as nitrous oxide. The lots also tend to be the largest source of ammonia emissions on the farm, because the cows are urinating on the lots, and then that uric acid breaks down pretty quickly to ammonium, and then it's lost as ammonia in a very short period of time. Manure that's deposited on the concrete aprons behind the feed lane is either scraped and piled in the lots sometimes. There are some dairies that might vacuum that and put it into a pit that'll eventually end up in the lagoon. And there are a couple dairies that actually flush those aprons to remove manure from the lots. And then typically what happens at the end of the season, they'll clean out all of these lots, and lots of guys will take it to a compost yard and they will compost it, and then that compost eventually gets land applied. But not every dairy composts. There are some dairies that will just clean it out, stack it as a solid, and then that manure will be land applied in the fall. On a typical open lot dairy, your largest ammonia sources tend to be from the lots, and then your second largest sources can be from the composting area and then the lagoons. When we look at nitrous oxide emissions, the largest emission sources on an open lot dairy tend to come from the feedlot, dry lots themselves, and the composting area. And then we actually do get a little bit of nitrous oxide emissions from the settling basins when they form really thick crusts. When it comes to methane emissions, it can be evenly split sometimes between the enteric methane emissions from the cows themselves and the housing area. And then one of the other biggest sources that we found is these small settling basins where the volatile solids contents tend to be really high, and they generate quite a bit of emissions before the lagoon water then flows into the lagoons, and then the lagoons are another additional source of methane emissions. Although we're not at a freestall dairy, we have done quite a bit of work at freestall dairies in both Idaho and California. And the emissions are a bit different when you're at a freestall dairy. The methane emissions tend to be pretty large from the barns themselves where the cows are housed, but then a secondary, very large emission source tends to be from the settling basins and the lagoons as well. We don't see as much nitrous oxide from freestall dairies, a very minimal amount from the housing area when the manure is moved quickly out of the barns, but again, we do see nitrous oxide emissions from any stored manure that is on the facility if they maybe separate their solids and do some composting, or we definitely see some again from the settling basins when they form really thick crusts. The ammonia emissions from freestall dairies tend to be about evenly split between the housing area and the lagoon system, because what's not lost from the housing area when it's immediately excreted tends to be flushed or moved quickly into the liquid storage system, and then that ammonia just tends to be lost from that section of the dairy instead. Many of the dairies that we work on have their own support animals on the farm, so that's included as part of the whole farm emissions. So for a lot of our dairies out here in the western US, calves are started in hutches, and then they tend to move to group pens and eventually to open lot areas. And the dry cows are actually usually housed in open lot areas as well. So that's a big difference from freestall dairies or dairies where they may not be raising their own replacement heifers on site. And these emissions are also included into our overall calculations.